Hi everyone, and welcome back to another video on the channel. And today we're going to be going through some applied practice for next week's paper. So I believe it's on the 18th is your final maths paper, which is applied. So we're going to be doing some practice questions on statistics and mechanics, just like a normal exam paper. And we can just follow through it the exact same way. So I'll pause whenever we get to a new question. You can have a go, and then you can also watch me work through it. If you have any questions, I just wanted to say thank you so much for the support on the previous videos. They were quite successful, I think, and a lot of people have been saying that they were really useful, and it definitely helped with the paper yesterday. So I'm happy to hear that people found it beneficial for them to watch them. And again, if you find this helpful, please like it, please share, please subscribe, so as many people can benefit as possible, and it also helps me out too. And without further ado, let's get started with question 1. So we can see here a researcher uses the large data set to investigate the daily mean wind speed, which is X knots, in Camborne. They take a systematic sample of 30 days from the data available in 1987. Explain how the researcher could select a systematic sample from a list of 184 available days. So systematic sampling is when we go at repeated intervals from a certain starting point. So the way we're going to calculate the interval is we're going to do 184 divided by 30, and that's roughly 6.1, I believe. Yeah, so it's 6.133 and so on. So then we can say, let's use a sampling interval of 6. Sampling interval of 6. Then the most important part is the next line. So we have to say that they pick a random number between 1 and 6. So a random starting point between 1 and 6. And then from there, you take every 6th item until you select 30 items, so 30 days. So you would say, choose a random starting point between 1 and 6. Between 1 and 6. And take every 6th item not item day, until 30 days have been selected. So it's important that you also give these answers in context. A lot of the time you have to give these answers in context. So we're talking about days here. So now let's move on to part B. So in the large data set, state the units used for daily maximum gust and explain what a recorded value of TR means. So daily maximum gust. So again, some large data set. I know lots of people aren't a fan of this. So if it's helpful, I don't mind doing a video on the large data set for people to go and revise with. And this is measured in knots. And then we could say that TR, so TR is trace. And this is when the rainfall is less than 0.05 millimeters. Rainfall is less than 0.05 millimeters. That's part B done. Now part C. So now they've asked us to calculate the mean and variance of the daily mean wind speed for the sample. And if you take a look at the information, well, the daily mean wind speed is X. So they're trying to ask us to find X, but they've given us some coded data because we've got the sum of X minus 10 and the sum of X minus 10 whole squared is equal to 250. So let's write down, and we're going to redefine X minus 10 as a different variable. So I'm going to say, well, let U equal to X minus 10. Because then that gives us the sum of U is 45. Let me rewrite that, 45. The sum of U squared is 250, and N is equal to 30. So let's calculate the mean and variance of U, and then we're going to translate that into the mean and variance of X itself. So we know that the mean of U is going to be the sum of U over N. So 45 over 30, which is 1.5. And the variance of U is going to be the sum of U squared over N minus U squared. So the mean of U squared. So we're going to use the values that they've given. So 250 over 30 minus 1.5 squared. And that gives us, we'll say 6.0833, which is, I am going to write it as a fraction because that will help me later on. I'm not sure why I didn't do that originally, but so we have the mean and variance of u now. Now what I'm going to write out is, so we know that u is equal to x minus 10. So using the coding, as we remember from what we've learned, the mean of u is equal to the mean of x minus 10. So the mean of x is equal to u plus 10. So the mean of x is equal to, well, the mean of u is 1.5, so 11.5 knots. Now, if we use the same thing, well, u equals x minus 10, we have to remember that standard deviation isn't actually impacted by adding anything onto the variable. So doing x minus 10, so that won't impact the standard deviation of x. So if we do x is u plus 10, well, that's not going to impact the standard deviation or variance of x. And same for u. It's not impacted by subtracting 10 from x. So we can say, well, the standard deviation of u is equal to the standard deviation of x. So therefore, the standard, sorry, let me put variance. The variance of u is equal to the variance of x. So that means that the variance of x is equal to 6.08. Sorry, I got a bit confused there. 3SF. So that is a question 1 done. So large data is a question. Not everyone's a fan of that, but hopefully that made sense. And now we can move on to question 2. So here we've got some probability questions. So we've got three events, A, B, and C. They've given us some basic information. So P of A is 0.3 and PB is 0.4. And we know that A and B are independent. And B and C are mutually exclusive. So let's just go straight into part A because it's asking us to find the probability of A intersection B. So we know that when two events are independent, their intersection is equal to probability of A times probability of B. So if two events are independent, their intersection is equal to the multiplication of the two individual events. So here, PA intersection B is PA times PB. So we can do 0.3 times 0.4, which is going to give us 0.12. So that's part A. Now part B, explain why the intersection of A, B, and C is equal to 0. Well, we remember that B and C are mutually exclusive. So as B and C are mutually exclusive, can't even write anymore, mutually exclusive, the probability of B intersection C is equal to 0. Therefore, the intersection of all three must also be 0. Must also be 0. So I'm going to write it in words, I'm not sure. So essentially, because if you think about it in a Venn diagram, which I'll draw it out in part C because we need it for part C, if two events are mutually exclusive, well then there's not going to be a shared intersection between all three. So that means that therefore the intersection of all three must be equal to 0. And now it's asking us to find the probability of C. So here I think a Venn diagram will help a lot. So my first step is let's draw out A and B. Okay, that's A, that's B. And now let's just remember B and C are mutually exclusive, so they cannot intersect because they can't happen at the same time. So therefore we'll draw C here. And here we can see that there is no single area on the Venn diagram where they all are where there's a single probability that lies inside of it. So here we can see here, well, yes, A and B occur at the same time, but C isn't involved there at all. And same if I highlight this point. So there's no single point where all three events occur at the same time. So now let's try and work out how do we find out the probability of C. So let's move this down, make this a bit bigger. Okay, so we have calculated a couple of things. So we know that this is 0.1. We know that this is 0.12. Let me redraw this. So let me redraw this because then it'll be easier to work with. So this is A, this is B, this is C. So A, C, B. So you know here this is 0.12 because we just calculated that. Okay, we also know that probability A is 0.3 and probability B is 0.4. So we can do 0.4 minus 0.12 to get this information here, which is 0.28. That's not really useful, but I'm just going to write it down there. The probability of A intersection C is 0.1. So we can say that's 0.1. And if we know that the whole circle, so we know that this whole circle here of A is going to be equal to 0.3. So then we can say, well, 0.3 minus 0.1 plus 0.12 is going to be equal to like this area here, where there's no like overlaps. So then we can say, well, this is equal to 0.08, because if we were to add all of these, so this one, and this one, we'll get 0.4, which is the 0.3, which is the probability of A. Now we have to find out, okay, what is the probability of C? So it says here the probability of A union B union C is 0.85. Okay, so actually, I don't think this is specifically taught in the textbooks, but I thought that this is a great way that you can apply your knowledge, because I still don't see how they can't ask this, because you just have to apply using Venn diagrams and also how to use Venn diagrams in the question. So I do think that this is possible. If you disagree, though, please let me know, and I can change it then. But let's write this out now. So we're going to add together everything, and it should come to 0.85. So 0.28 plus 0.12 plus 0.08 plus 0.1 plus probability of C minus 0.1 is equal to 0.85. Okay, so I've added together everything and made sure that I haven't included any overlaps. Okay, and the reason I did subtract 0.1 is because if I had just left it as probability of C, I would be counting 0.1 twice. So as this equals to 0.85, let's simplify the left-hand side. So 0.28 plus 0.12 plus 0.08 plus 0.1 minus 0.1. So that becomes 0.48. So probability of C plus 0.48 is equal to 0.85. Now let's just do our final subtraction to get probability of C is equal to 0.37. And, oh, let's just fix that. So that means that probability of C, so this is 0.27 here. And a really great way to check is, let's just make sure this all adds to 1. So 0.27, this adds to 0.85. 0.27 plus 0.1 plus 0.08 is 0.12 plus 0.28. That adds to 0.85, which is exactly what they've given here. So now we can, we're confident in our answer that 0.37 is the probability of C. So now let's move on to part D. So now for part D, they're asking us to find the intersection of the complement of A and the complement of B. So I am going to use the same diagram. So I'm just going to duplicate it and I'm going to bring it down here. But what we're going to add now is we're going to make sure that we add the surrounding box so we don't forget it. Because if you remember that this doesn't actually add to 1 because we have a little bit of space on the outside. And if the union is 0.85, so everything in these three events adds to 0.85, well, as the probability always sums to 1, we must have 0.15, which is not part of any event. So the probability of none of them happening is 0.15. So now let's think. The probability of not A intersection not B. So let's first look at not A. Not A involves, I'm going to highlight in green, everything that is not A. So 0.27, 0.28, and also 0.15. All of these are represented by the event not A. Okay, let me highlight that in green. Now, not B. What is not B? Not B is going to be this blue shape here, as well as this shape here. So this shape here, and then also this one here. So hopefully the colors aren't too confusing, but my main point is that when we're trying to find intersections, we have to find where do they occur in both events. Okay, so not A intersection not B, which event occurs in both? So what happens in both not A and it happens in not B? So we can see here, the reason I went around with that blue color in the shape of C is because we can see that that specific that 0.27 shape occurs both in not A and in not B. Okay. And that 0.15 occurs in both not A and not B. Whereas, for example, if you think about the 0.1 here, that only occurs in not B. It doesn't occur in not A. So you have to find the events that happen in both not A and not B. So that is 0.27 and 0.15. So we can say that probability of A, not A intersection not B is 0.42, because those are the only two probabilities which happen in both not A and not B. So hopefully that makes sense. And we can move on to our final question, which is conditional probability. So let's write this out straight away using the formula that we know, which is probability of A intersection B union C over probability of B union C. So let's break down the numerator. Okay, so A intersection B union C. I'm going to copy this diagram, so I'm going to take the original one that's not annotated. Let's move this down. And we're going to draw the box again outside of it to remember this 0.15. So let's start by looking at B union C. This is B, and this is C. So B union C is just going to be, it will just be those two together. There's no intersection, so we don't have to worry about there being an intersection. It's just 0.4 and 0.37. But it's asking us what is the intersection of A with B union C? So the blue circles represent B union C. Where does A intersect those two, such that A happens at the same time? Well, if we draw a circle here, you should be able to see that there's two intersections. A intersects B union C at 0.1 and 0.12, because that's where the overlap is. So we can say that the probability of A intersection B union C is going to be 0.12 plus 0.1, which is 0.22. Okay, so I'm going to repeat it again just in case anybody didn't understand. B union C is the two circles in blue, because that is the B union C is what is the probability that they both happen. It doesn't have to be an intersection. We're just looking at together. So if we're looking at A intersection B union C, it's what is the event such that A occurs at the same time. So A occurs at the same time as B union C. So we highlight A with a green circle. And we can see there's only two intersection points with B union C. There's only two intersection points with the blue circle. And that occurs at the overlap with 0.12 and 0.1. So we can just add those together to get 0.22. Now we can look at the denominator. Well, we just highlighted the probability of B union C. It will literally just be 0.128 plus 0.12 plus 0.1 plus 0.27, which is equal to 0.77. So therefore, the probability of A given that B union C is equal to 0.22 over 0.77, which is equal to 22 over 77, which is 2 over 7. So hopefully my explanation made sense. I tried to link it and explain it as well as I could with Venn diagrams. So hopefully everyone understood that method for all of these parts up to E. And now let's move on to question 3. So question 3 is now giving us some information on some defective light bulbs. So we've got a manufacturer of LED light bulbs claims that only 5% are defective, and they've taken a random sample of 40. So my first step is let's define X to be the number of defective light bulbs. Defective be the number of defective light bulbs in a sample of 40. A sample of 40. So we know that XB is going to be 40, 0.05. Now the probability that X is greater than or equal to 3 is going to be the probability 1 minus the probability that X is less than or equal to 2. And the probability that X is less than or equal to 2, of course, is 0.6767. Really hope that comes up in the paper. And that gives us an answer of 0.3232, which is 0.323 to 3SF. Okay, so that's part A done. And now we can move on to part B. So 6 marker, we got hypothesis test now. And they claim that the proportion of defective light bulbs has decreased. So that should be a hint as to your alternative hypothesis. And then now I'm taking a different sample, so I'm going to redefine a variable. And we've got 2. Exactly 2 have found to be defective. So first step, redefine a new variable. So let y be the number of defective bulbs in a sample of 100. So we're going to write down our hypotheses now. So our null hypothesis is that it stays the same. And our alternative hypothesis is that it's decreased. So P is less than 0.05. Assume H0 is true. That's our first step. And I'm going to write down here, just so I don't forget, the significance level. So now we can write our distribution as 100, 0.05. Now, how do we calculate? What's our next step? So we're going to find the probability that y is less than or equal to 2. And we're going to use 2 because they said there's exactly 2 that are found to be defective. And the reason we use less than or equal to is because we're going to follow the sign of our alternative hypothesis. That's the way that I used to remember it. So because it's less than 0.05, we're going to find less than or equal to 2. So we're just going to put that into our calculator, and that is going to give us an answer of 0.118, 0.11826. Okay, and now let's compare that to a significance level. So this is clearly greater than 0.05. So what can we say? There is insufficient evidence to reject H0. So we can say there is insufficient evidence to suggest that the proportion of defective light bulbs or bulbs has decreased. So there is insufficient evidence to suggest that the proportion of defective bulbs has decreased. So I'm just going to put, because you should also say, I forgot to link it into the first line, but insufficient evidence to suggest that insufficient evidence to support the manager's claim. To support the managers or manufacturer's claim. So there is a lot of different ways that people write their conclusions, but the main thing is, first of all, say it, you're rejecting, accepting H0, what is your thing, and then give it in context. So always give your conclusion in context, otherwise you miss your last answer mark. So that's how you do question 3, so a binomial question. And now let's move on to question 4. So for question 4, we've been given some information over a particular breed of bird, and it's modeled by a normal distribution, and they haven't given us the actual values for the mean or the standard deviation. All they've said is that 10% of the birds weigh more than 300 grams, and 5% weigh less than 200 grams. So they've already defined it for us, which is great. So we're just going to write it out as such. And now let's start by writing out the information that they've given us. So the probability that W is greater than 300 is 0.05, which means, not 0.05, sorry, 0.1, which means that the probability that W is less than 300 is 0.9. So let's work with this information. We're going to write this out. We're going to standardize it. So if we use inverse normal in our calculator, so I'm using the standard, the science calculator, the scientific one. So I'm going to use the area to be 0.9. Okay, and I'm going to make my standard deviation 1 and my mean 0. That gives me an answer of 1.281 and so on, so on, so on. So what this means is that W minus 300 over the standard deviation is equal to 1.28155, so on, so on, so on. Sorry, I wrote that wrong. Let me fix that. It means that 300 minus the mean is equal to that. So what we've done here is we've standardized the variable. So we've done 300, which is W, minus the mean over the standard deviation. And I've set that equal to 0.9 using the inverse function of my calculator, using the standard deviation 1 and mean of 0. And that gives us this equation. So one thing that I always used to do in exams is I used to say, so I'm going to store this to A, because it means that my answers are always more accurate. And it also means that when I'm writing it out, it's so much more easier, because now I can rewrite this now as 300 minus mu equals A sigma. So that's my first equation. Now let's work on my next one. So it says here, probability that W less than 200 is 0.05. So again, I'm going to use the exact same method. I'm going to use the inverse normal instead with an area of 0.05. And I get minus 1.644, so on. So I can say 200 minus mu over standard deviation, so again, standardizing it, is equal to minus 1.6448, and so on. So I'm going to store this to B. Because again, I can now write this as 200 minus mu equals B sigma. So I'm going to label this as equation 2. Now, the first step here is let me just do equation 1 minus equation 2, because that's going to instantly get rid of my mean. So I can find my standard deviation. So 1 minus 2 will give me 100 equals A minus B sigma. So sigma is equal to, so I'm going to, now, this is where my storing value helps. So I'm going to do 100 over A minus B in my calculator, which gives me 34.1716 equals 34.2 to 1 dp. But again, I'm going to store this value here to C, because I'm going to use that to find mu. I don't want to use my rounded value to find mu. I'm going to store my unrounded value to C, because now I can say that mu is equal to 200 minus B. So I'm using equation 2 here. 200 minus B, 34.171, so on. So mu is equal to 200 minus BC, and that gives me an answer of 256.207, which is 256.2 to 1 dp. So this is a very standard question that people you get asked. Sorry, I got a bit confused with my standardization and writing it down. But I think one thing that definitely helps is storing your answers in your calculator and using them later on, because it means that your working's cleaner. It means that you're using unrounded values, so your answers are more accurate as well. So hopefully that makes sense for part A. Let's shift on to part B. So using your values for mu and sigma, find the probability that a random chosen bird of this breed weighs more than 280 grams. So probability that W is greater than 280, or we can just put this into our calculator. Again, so I am going to now store this to D. Actually, no, using your values for... So here, I would suggest using your rounded values, because it does say using your values from mu and standard deviation sigma, and they asked us to give it to 1 dp. So here, using your 1 dp one is fine. So our lower will be 280. I'm going to set my upper to very high. 34.2 to 56.2. And you should get an answer of 0.243 to 3SF. So ignore the marks here for this one. It shouldn't actually be 4 marks. So sorry about that, but hopefully that's still good practice. And now let's move on to question 5. So now our final question on the statistics part of the paper is a PMCC question. So they've given us a table of data, and they first of all want us to just find the product moment correlation coefficient between the two, between X and Y. So I'm going to start by just substituting these values into my calculator. 29, 32, 35, 38, and 42. And for my Y values, I'm just going to sub those in as well. 65, 75, 78, 85, 85. And regression calculation. That gives us an answer of 0.9957, which is 0.996 to 3SF, because I always, unless it specifies otherwise, I always use 3SF for these kind of values. And I carry out a hypothesis test and to determine if there's a positive linear correlation. So our null hypothesis will be that there is no correlation. And our alternative hypothesis is that there is a positive correlation. So we're going to have to use the formula book, and it's going to give us, because we have got 10 observations, okay, our critical value. So we've got 1% significance level. So 1% level and n is equal to 10. So our critical value is equal to 0.7155. No, just 0.7115. I'm not sure I put dots there. And as 0.996 is greater than 0.7155, we can reject H naught. And because we are greater than the critical value, we can reject it. So therefore, we can say there is insufficient evidence to suggest that there is no correlation between X and Y. Between X and Y. So I've always been taught to write my conclusions like this. If you have another way of writing it, just make sure that it's correct and also that you give it in context of the test. So that's how you would carry out part B. Now part C, find the equation of the regression line of Y and X in the form Y equals A plus BX. So actually when you use your calculator, they actually give all of the values that you need. So here we have that A is equal to 25.784 to 3 significant figures. That's 25.8 to 3SF. And they even give B as well, which is 1.668. So again, 1.67 to 3SF. So it'll be Y is equal to 25.8 plus 1.67x. Don't need brackets there. 1.67x. So now part D, give a practical interpretation of the value of B. So if we think about it, that is just the gradient because it's Y equals mx plus c. So m is 1.67. So every time we increase, so for a unit increase in x, for a unit increase in x, the value of y, the value of y rises by approximately 1.67. And I promise you I did not put these numbers on purpose. By approximately 1.67. So that's part D done, so another 1 mark there. And the data is coded using the formulas u equals x minus 10 over 2 and v equals y minus 5. Okay, so actually, let's think about this logically. We're changing each of the x values by the same. So we're doing x minus 10 over 2 and we're doing y minus 5 for each of the values. So how would that impact our PMCC? So if we think about it, all of our x values are going to change to exactly the same scaled version of themselves. So they will all be, you all subtract 10 for all of them and divide by 2. And you're scaling the y values by exactly the same. So actually, the relationship between both of them will stay the same. So no matter how you scale it, no matter any kind of linear coding that you're doing, your relationship between the two will actually stay the same. And you can test this out if you want. If you want to put it into your calculator, you can see that your PMCC does not actually change with the linear coding. So again, this is kind of an application of some of the knowledge that you might have. I can't say for certain if this is something that they could ask, but I'd say that this is just generally good knowledge to have, that coding does not affect the PMCC. So that would mean that R remains as 0.996 to 3SF. Now use your equation from part C. Find the equation of the regression line of V on U in the form of V equals C plus DU. So what is our equation? So we have Y equals 25.8 plus 1.67x. So you might be thinking, okay, well, how do we even do this? So all we're going to do is we're going to use the information that they gave us in part E and do a little bit of substitution. So we know that 2u is equal to x minus 10. So x is equal to 2u plus 10. And we know that v, so y, is equal to v plus 5. So why don't we just substitute this in? So v plus 5 is equal to 25.8 plus 1.67 2u plus 10. So v equals 20.8 plus 1.67 2u plus 10. So v is equal to 20.8 plus 3.34u plus 16.7. So that doesn't look very clear. And now let's just simplify this to get, that should be 4.1 plus 3.34u. So that's part F done. And now we can move on to part G. Let me just double check my calculations. Don't want to make a mistake by accident. So yeah, I think I'm good. Except from the fact I did a subtraction. I'm not entirely sure why I did a subtraction here, but so this should come to 37.5. I hope so. Well, my maths has been pretty bad today. Yeah, 37.5 and 3.34. So now we can move on to the final part of the stats paper, which is explain why it might not be reliable to use your regression line to estimate the value of y when x is equal to 60. So from part C. So we can see here that we don't have x is 60 is too far outside of this range from 12 to 42. So we're going to use the fact that it's extrapolation. So x equals 60 is too far outside the range of 12 to 42. This is therefore extrapolation which would not give a reliable estimate to the for the value of y. And the reason for that is because we don't know if the linear relationship continues beyond the recorded data. So we don't know that after x equals 42, is that still that relationship between x and y. So that's the main reason. So hopefully the stats has made sense. Sorry about a little bit of confusion. Maybe the marks weren't as accurate for one of the questions, but hopefully it was still good practice. And we can now move on to mechanics. So we've got a particle P that's moving on a horizontal plane, and we've been given its velocity in terms of v, in terms of t. So let's work on finding the acceleration vector when t is equal to 2. So we know that to get to acceleration from velocity, we have to take the derivative of our velocity function. So we're going to have to take the derivative of v with respect to t. So let's start working that out. So dv by dt is equal to 3t minus 3i plus 6j. So that is equal to a. Now when t is equal to 2, all we're just going to do is sub in t is 2. We're going to get 6 minus 3, which is 3i, and then plus 6j. So we're just going to write it out as 2t. Oh, sorry, there should be a 2t minus 3. So let me rewrite that. Sorry about that. So when t is equal to 2, we're going to get I plus 6j. So that would be our acceleration at that point. Sorry, I got a bit confused there. So now let's move on to part B. So find the exact values of t for which the particle is moving parallel to the vector I plus j. So with these questions, you should always see, okay, what is the relationship between the I component and the j component? So if it's moving parallel to I plus j, we're going to say, okay, well, at that point when it's moving, the I component is going to be equal to the j component. Because you can see here the coefficient of I is 1 and the coefficient of j is also 1. So we're going to set that for the velocity, we're going to set the I component equal to the j component. So we're going to set t squared minus 3t plus 4 equal to 6t minus 2. So t squared minus 9t plus 6 is equal to 0. So therefore, I don't think this factorizes. This doesn't factorize. So we're going to use the quadratic formula here because it's asking us for the exact values. So I'm going to say, well, t is equal to 9 plus or minus square root b squared minus 4ac, so minus 4 times 6 all over 2a, which is 9 plus or minus root 57 over 2. And let's just double check. I believe, yes, so both roots are going to be positive because that's less than, root 57 is less than 9. So they're both going to be positive. And what I am going to do though, I do want to quickly check to make sure that when I sub this in to both my I component and my j component, they should give the exact same value. So I am going to check that just in case. So if I sub that into my I component, I subbed in 9 plus root 57. I get 25 plus 3 root 57. Now let me try it on the left-hand side. And I get the exact same answer. So that showed me that my roots are fine. And there's the exact values of t for which the particle is moving parallel to I plus j. Now let's look at part C. Given that the position vector of p is the 0 vector when t is equal to 0, find the position vector of p when t is equal to 2. So to get the position vector from the velocity vector, we're going to have to integrate with respect to t. So we're going to take the integral. So we're not having any bounds here. Of v with respect to t, that is equal to r. So that is equal to the integral of t squared minus 3t plus 4. So I'm going to write it in column notation now. And then 6t minus 2. So let's write this out now. So the I component is going to be t cubed over 3 minus 3t squared over 2 plus 4t. Then the bottom one is going to be 6t squared over 2, so 3t squared minus 2t. And then let's not forget plus c1 plus c2, because that we have to have our constant of integration. Now let's use the information that the position vector of p is the 0 vector when t is equal to 0. So r is equal to 0 when t is equal to 0. So let's sub in t is equal to 0. We get, well, both the I and j component will turn to 0 because they all have a t. So we're going to get 0, 0, 0 is equal to c1, c2. So therefore, we can say that r is equal to, not the integral, sorry. R is equal to t cubed over 3 minus 3t squared over 2 plus 4t I plus 3t squared minus 2t j. So that is our r, but we're not done yet because it's asking for when t is equal to 2. So let's sub in 2. We're going to get 8 over 3 minus 12 over 2 plus 8 I plus 12 minus 4j. So we get r is equal to, that should come to 14 over 3, I believe. So 14 over 3, because that's 8 over 3 plus 2, which is 14 over 3i. And then that's just going to be 8j. And then meters. Let's not forget our units. So that's how we do question 6, so our first question of mechanics. And now let's move on. Being asked to work on a connected particles question. So we've got two particles A and B, and they've got two masses of 2m and 5m respectively. They're attached to the ends of a light inextensible string, and we can see it's on a rough plane inclined at an angle of alpha. So let's just draw that here. We've got alpha here, and we've got a particle A. Let me shift this down here, which is mass 2m. So this will be 2mg. And it says it's a rough plane. So I'm going to label my R. And we've got a pulley. And there's a string that goes across it. And B hangs perfectly below it. So 5mg. And we've definitely got tension here. And it's the same because it's a light and inextensible string. So the coefficient of friction is 0.4. And the system is released from rest with a string taut. Okay, so actually, funny enough, the question doesn't actually say if it's going up or down. Normally, you can just assume, because a lot of these questions it says that it's, for example, B is going down, or and then A that therefore is going up towards the pulley. But I'm just going to do a quick calculation just in case. So we know that B is going to have its weight is 5 mg downwards. Let's see what is A contributing. I want to specifically find out what is this weight component there, because that's what's going to be contributing to it going down the slope. So we know that this here is alpha. Let me shift this to the left-hand side. And we know that we got 3 over 4 here. And if you know your 3, 4, 5 triangles, that'll be 3, 4, 5 there. So the weight component is going to be 2 mg sine alpha. So I'm just going to calculate that quickly. 2 times 9.8 times 3 over 5. That's 2 mg sine alpha. And that is going to be your weight component of A going down. Okay, so that's 11.76 roughly. Now let's try 5 mg. So 5 times 9.8. That is much bigger. So therefore we know that it's going to be B that's going down. That is just kind of a check just to make sure. Not very necessary, but because the question didn't actually specify that. So now let's just work on, just going to separate here for my working out, finding the acceleration of the system. So as we know, B is now going down. Let's write down our first equation. So force is mass times acceleration. So for B, 5 mg minus T is equal to mass times acceleration. So 5 ma. That's equation for B. Now let's look at A. Because now we know that A is going up, we can say we've got friction acting to the left. So let's work. I'm just going to write down the equation first, and then below that, I'm going to work out each individual value. So going up, we have T, and then we have minus 2 mg sine alpha plus Fr is equal to mass times acceleration. So 2 ma. Now let's work on finding out the friction. Okay, so we know that friction is equal to mu times r. If we resolve vertically, we can see that r is equal to 2 mg cos alpha, which is equal to cos alpha is 4 over 5, so 8 over 5 mg. So we've got our r value, so therefore we can find our friction by saying friction is equal to 0.4, so 2 over 5 times 8 over 5 mg, which is equal to 16 over 25 mg. So that is our friction component. So now we can write this a bit better. T minus sine alpha is 3 over 5. So 6 over 5 mg minus 16 over 25 mg equals 2 ma. So that's A. So minus 6 over 5 becomes minus 30 over 25. So it's minus 46 over 25 mg equals 2 ma. This is A. And we also have that minus T plus 5 mg equals 5 ma. And what are we looking for? We're trying to find the acceleration of the system. So we're going to want to cancel out the T's. So let's add together 3 and 4. And we're going to get minus 46 over 25 mg plus 5 mg equals 7 ma. Okay, so we can rewrite this as, I'm just going to double check it, I don't want to make a mistake. Minus 46 over 25 plus 5 gives us 79 over 25. So this does look good so far. Mg equals 7 ma. Now what we're going to do is we're going to divide by 7m. So we're going to get 79 over 175g meters per second squared, and it's to show that, so we know that we've got this answer right. So a nice connected particles question. Just as I said before, it's a good thing to check because it does not say that in the question. I thought it was a good idea to just check it just in case. But now we can work on part B, which is find the tension in terms of m and g. So let's use one of the simple equations. So 5 mg minus T equals 5 ma. So we now know where A is. So we can say 5 mg minus T equals 5m 79 over 175g. So this becomes 5 mg minus t equals 79 over 37 mg. I hope that's right. I'm just going to double check. 30. Whoops, that's quite bad. 35. Yeah, that's quite bad. And then that gives us t is equal to 5 minus 79 over 35, which is 96 over 35 mg. So 96 over 35 mg. I'll put newtons. So that's part B done. And now we can move on to part C. Find the magnitude of the force exerted on the pulley by the strings in terms of m and g. So my first thought is to draw a diagram. So if we kind of draw a pulley as this, I'm going to draw a continuation. So I'm going to draw P and T here. And the reason I'm doing that is because I'm kind of continuing. So this is our pulley, right? I'm continuing the line from B upwards to get this, and the line from A across to get this. So you can kind of see how this diagram works here. And now for the angle. Well, we know that this is going to be, so I'm going to label it in green. This is going to be 90 minus alpha. Because if we draw like a line down, kind of think about this as continuing the diagram, that green line. This is a right angle triangle. So that green label here has to be 90 minus alpha. And therefore, via opposite angles, this is also going to be 90 minus alpha. So we can say here, this is 90 minus alpha. But it's important. So a mistake that students make is they think, okay, I can just connect the two here, and that is going to be my resultant force. But that's not how it works, because that's going to instead find the difference between the two vectors. We have to draw it as a tip to tail. And the best way I think about it is these two are going in different directions, so you can't just join them together. So instead, what I'm going to do is I'm going to draw a dashed line. Okay, this is still T. Okay, but now I can join these, because you can see here, it starts here and it ends here. And then this line starts here at this dot, and it ends here at this dot. So we're essentially starting here and we're going to end here, which allows us to draw this dotted line. Okay, whereas here, that's just not allowed at all because they're going in different directions. So now our goal is, let's find the magnitude of this line here. So we know that this is a straight line. This is a straight line. So this angle here, I'm going to label it as, well, I can just label it straight away as 180 minus 90 minus alpha. So like this. So that gives us 90 plus alpha. Because if you add the two together, you get 180. Now let's work on finding that magnitude. So we can use the cosine rule. So we can say that side, we'll label it x. X squared equals t squared plus t squared minus 2t squared cos 90 plus alpha. Okay, so x squared equals 2t squared minus 2t squared cos 90 plus alpha. Okay, so there's a couple of ways that we can do this, but I think it's best that we have to do it in terms of m and g. So let's think, how can we write cos 90 plus alpha to help us with this question? So first, let's just root this. 2t squared minus 2t squared cos 90 plus alpha. There's a couple of ways that you can do this, but what I'm going to do is I'm just going to write it out. I'm going to expand this double angle formula after I take out root 2t squared, because then that gives me 1 minus, now let's write this out, cos 90 cos alpha. Okay, now it's a plus, so it'll be minus sine 90 sine alpha. So that will give me root 2t squared. Let's think about the actual values here. So cos 90 is what? Cos 90 is 0. So that gives me 1 plus sine 90 sine alpha. Sine 90 is 1. And we know from above, sine alpha is 3 over 5. So this turns to 0, and we get 1 plus 3 over 5. So we can write this as t root 2 root 8 over 5 And now we can just expand this, and we can say, what did we calculate t to be? 96 over 35 mg. 96 over 35 mg times by root 2 times by root 8 over 5. So that gives us an answer of 96 over 35, so times root 2 times root 8 over 5. It hasn't said that we have to give it an exact form. So first, let me simplify the surds. So I'm going to get 4 root 5 over 5 times 96 over 35 mg. But we can just leave it in an exact form. So if we do 96 times 4 root 5, we're going to get, well, it doesn't actually help. So I'm going to do 96 times 4, which gives 384 root 5 over 35 times 5, 175 mg. So this is going to be the magnitude of the force exerted on the pulley by the strings in terms of m and g. So that's part C done. A little bit of a difficult question. It's very important how you visualize it, but hopefully the explanation made sense. So we've been told that there is a particle that's being projected from the horizontal ground with speed u at an angle of theta above the horizontal. So we think about it as something like this. This is u. We can split it up into two components. So we have u sine theta and u cos theta. So that's what the question has told us. And they want us to show the equation of the trajectory of the particle is given by the following. So y equals x tan theta minus gx squared over 2u squared 1 plus tan squared theta. So a lot of the time, these proofs follow roughly the same kind of step. So I'm just going to label the horizontal as x and the vertical, like displacement, by the way, I mean distance, sorry, as y. So x and y. So let's start working out here. So we know that in the horizontal component, there's no acceleration. So we're going to be operating with, there's going to be a constant speed. So we can label s as just ut, which means that, so x equals ut because the horizontal. So it means that x is equal to u cos theta t. So t equals x over u cos theta. That is, we don't have to look at the horizontal for now. Now what we're going to use is we're going to use the vertical. So we're going to use the equation y equals ut plus half at squared. So y equals u sine theta t minus half gt squared. So I put minus a half g because we're going to define upward as positive. So that means that g will be acting downwards. So it's going to be acting in the opposite direction. So we use minus g. So then we can now substitute in our t. So we get y equals u sine theta x over u cos theta minus a half g x over u cos theta whole squared. So we can see that the left-hand side of this equation, so on the right-hand side of the equal sign, is done. We've matched that up completely because we've got x tan theta. Now the right-hand side, let's fix this so it looks better. The right-hand side, let's try and think, okay, how can we get it as close to that as possible for now? So let's work on taking out that. We're going to take the x squared over u squared. So we get minus gx squared over 2u squared 1 over cos squared theta. What is 1 over cos squared theta? Well, 1 over cos squared theta is the same as sec squared theta. So y is equal to x tan theta minus gx squared over 2u squared sec squared theta. And what's another identity that we know? Sec squared theta, let me write it over here. Sec squared theta equals 1 plus tan squared theta. So we can see here now we have finished the question, because once we substitute that in over 2u squared 1 plus tan squared theta, that's all that we need to do. So that is part A done. So a nice little show that. And we can now move on to part B. So now we have to find the two possible values of the angle of projection theta given some information that we've been given. So we have now been given the speed and two, so a set of coordinates, so an x coordinate and a y coordinate. So I'm just going to write this down that u is now equal to 20, x is 30, and y equals 5, because those are those are values that happen at a certain time t. So y equals x tan theta. So 5 is equal to 30 tan theta minus 900g, because that's to x squared. And then u squared is 400, so 2u squared is 800, 1 plus tan squared theta. So I can see here we're going to get a quadratic of some sort. So my first step is let's try and simplify this. So 5 equals 30 tan theta minus 9 over 8g minus 9 over 8g tan squared theta. So I have like expanded and also simplified that fraction outside that 1 plus tan squared theta bracket. Now let's move everything onto the left-hand side. So we'll get 9 over 8g tan squared theta minus 30 tan theta plus 5 plus 9 over 8g equal to 0. So this is going to give us, let's just simplify each of the coefficients. So 9 over 8 times by 9.8 gives us 11.025. 11.025 tan squared theta minus 30 tan theta plus 5 plus 9 over 8g, almost forgot the g there. That gives us 16.025. So now, let me put this into my calculator and see which two values I get. Minus 30, 16.025. So I get tan theta equals 1.991. And again, I'm going to use that trick. I'm going to store it to A. That's why I'm writing bracket A above. And the second value is equal to 0.7300. And I'm going to store this to B. So now this is going to give me two values. So theta is equal to, so I'm going to use here tan inverse, make sure I'm in the right angle, so I'm in degrees. So tan inverse of A, 63.332 equals 63.3 degrees to 1 dp. And then the other option is tan inverse of B, which is 36.130 whatever, equals 36.1 degrees to 1 dp. So theta equals 63.3 degrees, or theta equals 36.1 degrees, both to 1 dp. So hopefully that working out made sense, and we can now move on to the last part, which is part C. So for the larger of these two angles, find the total time of flight of the ball before it returns to the horizontal ground. So we're going to use theta equals 63.3 degrees to 1 dp. Okay, so I'm going to use the rounded value here for this part here. Actually, so I'm going to write down the rounded value, but in my calculations, I might actually use the unrounded value. And the way that these work is the examiner or the mark scheme usually gives a range, and they do accept if you use the unrounded value. And I've always been taught to use the unrounded one. So find the total time of flight of the ball before it returns to the horizontal ground. So if it returns to the horizontal ground, that means that the vertical displacement is 0. We can use the formula that we taught, which is T is equal to 2u sine theta over g. So this is given, and this is kind of one that you can know, or you can derive it if you do forget it. So let's sub in our values now. So T equals 2 times 20 times sine of theta, so sine of 63.33 over g. So this gives us a value of, let's see, so 2 times 20 times sine of A over, so sorry, sine of the tan inverse of A all over 9.8. That gives us 3.64744 equals 3.65 seconds to 3SF. So I did say, by the way, sine of the tan inverse of A. And the reason is because I had only stored this. I hadn't actually stored the angle, the unrounded angle. So to get the unrounded angle, all I did was the tan inverse of A, and I took the sine of that. So that's just how I did it using how I stored it in my calculator. And that is actually now the end of the paper. So I hope this was useful. you might have felt that some questions were a little bit different compared to what you've seen. But one of the main reasons I do that is because I want you guys to apply the knowledge that you learn to like difficult questions or unseen kind of questions, so to make sure that you understand the topic and the content that you're learning. So hopefully this was good. I hope to do a couple of more videos, maybe 2 to 3 before Thursday's paper. So any kind of feedback, questions, anything, anywhere you think I went wrong, please drop a comment or email me, and I'm happy to fix, correct it, or help you with anything you need. And if you want certain topics to be covered, if you want the style of questions to be changed, also let me know so I can do that for the next video. And if this was useful, please like it, share it, and subscribe so as many people can benefit as possible. And it also helps me out a lot. And all the best with your revision, and I'll see you guys in the next video.